Now, welcome to today's class. Today I have an amazing topic to discuss with you people. Now, the unit I want to deal with today is all about thermodynamics. Under thermodynamics, we have a topic of today under electrochemistry. Now, within the topic, I want us to just look a bit on a subtopic known as stoichiometry of Faraday. Yes, so under stoichiometry of Faraday, I have an equation here that probably will enable you to understand the subtopic of study today. Now the question is now if 306 coulomb of charge is passed through a solution of copper to nitrate during an electrolysis experiment, the question is, what is the number of moles of copper metal deposited at the cathode, given that 1 Faraday is equals to 96,500 coulomb. So friends, you've been provided with such like equation under stoichiometry of Faraday, then you are being told to solve that equation appropriately. And therefore, you need to begin by writing their solution, because that's what we want to get. Now, what is the solution to the provided equation? Now, the question wants you to get the number of moles of copper metal. So that is it. And therefore, you need to be knowing the appropriate formula on how to calculate the number of moles of copper metal being deposited at the cathode. And today I want to give you the simplest approach of which you can get to know the number of moles of copper metal. Now the formula I want to give you today is that when you want to get number in chemistry, you just write NO that way to represent a number. So number of moles of copper metal being deposited at the cathode. The formula is you get the charge over N times the Faraday constant. So this is the amazing formula I've come up with to enable you to answer this question either as easy as possible. Now, your work now is to get to know whether you've been given a charge, you've been given N as well as Faraday constant. And as you can see here, we've been told that if 306 coulomb of charge is passed, and therefore my charge here shall be 306, then I have here N. Remember, since copper is a positively charged metal, obviously it must be deposited at the negative terminal of the battery, and the negative terminal of the battery usually is the cathode. So we shall be writing the equation showing how copper is being deposited at the cathode. And the equation is here and right now. So equation at the cathode. Yes, so how can I write that equation at the cathode here? Remember, at the cathode, to show that electrons are gained, the electrons we must show them at the reactant side. Since electrons being shown at the product side, that one will show that electrons had been lost. But here, copper is gaining electrons. And therefore, we shall write that we have copper, because copper is in an ion, so that is an ion state, that is aqueous, therefore, plus electrons, because electrons should be gained so that we can get copper solid there. So we need not to reach here, because we must ensure that we balance the charges there. So to balance the charges, you shall consider both product and reactant side. And here with me, On the reactant side, I have 0 charge because copper is 0. While on the reactant side here, I already have 2 plus here and a negative here. So that when I take these two, electrons are negative. So 2 minus 1 is 1. It will not be equal to 0. And therefore, I must use appropriate coefficient that which when I put an electrons here, I must get 0 because the product here is 0. The appropriate coefficient here is 2. So that when I take 2 minus 2, because electrons are negatively charged, so 2 minus 2, I'll come up with 0, and that's it will be equal to the 0 on the product side. And therefore, my charges are balanced. Now, after balancing the charges now, you will be in a position of getting N, because N we come up with 2 there. Now, after getting N, the charge we were given, as well as the Faraday constant is here, our work is just to substitute the content we have now. Now, what is the charge? I've told you that the charge is now 306 coulomb there. So I'll come up and say now, the number of moles of copper being deposited should be equals to the charge. And what is the charge here? The charge is 306, so I'll write 306 here over N, and my N here is 2 here, times the Faraday constant, and the Faraday constant is 96,500. So I'll come and say 96,500 there. Now, when you work out this, or you can use the calculator of yours by so saying that is 306. When you divide by 2, again you divide by 96,500, you will end up by getting that is 1.585, it is C times 10 raised to negative 3. Whereby when you eliminate the power here, you shall just come up with 0 point, because it is raised to 3. It's like we are dividing by 1,000. So when you divide this by 1,000, you'll come up with 0.00158 moles. Yes, so you will have gotten the number of moles of copper being deposited at the cathode. Otherwise, having concluded getting the number of moles of copper being deposited at the cathode, you will have gotten what the question requires you to get. Otherwise, just follow the comments and the key areas I've quoted so that you can be able to understand the questions under stoichiometry of Faraday. Otherwise, let's meet in the next lesson. Bye.